So welcome to this technical presentation in audiology testing applications. My name is Kim Lumholtz and I'm from G.R.A.S Sound and Vibration. We are a company that manufactures measurement microphones for many different purposes. So I would like to explain a little bit further about the products in audiology area. So the agenda for this presentation would be to talk a little bit about ear simulators, elaborate on the different types, and what the purpose of the measurements done in this field. Talk about mouth simulators, a mouth simulator that is simulating the speech of a human being, and also head and torso simulators to reflect a human torso, which both have the mouth and the ear built inside. Then we have different acoustic test fixtures. This can be test fixtures for telephone testing or different kind of fixtures that need to test the acoustic performance of different electronic equipment. So to go into the different areas that we have products for. We have products for headphones, for headphone testing, where you have a headphone on your head to calibrate the speaker inside the headphone. We have earphones, which are located inside the head, and we have equipment to test this kind of equipment as well. Headsets, where you have a combination of ear and microphone for communication and test of the quality of communication. We have special hearing protector test fixtures to test for health and safety issues for human beings to make sure that the noise level is not damaging to the ear when you wear the hearing protector. We have a lot of equipment for testing hearing aids for elderly people that cannot hear. You can get a hearing aid to turn up the volume of the sound and then making them able to hear as with better performance. Telephone testing, the communication through telephones. We can test the ear and the speaker. So the first product that we have is an artificial ear. It's designed according to IEC standard 60318. This is the 43AA ear, and it looks like this. So this ear is an artificial ear that represents the human ear, and this is the opening of the ear. So it's a mechanical structure which is very, you can do repeatable measurement on testing ears. It consists of these products. You have a microphone, a pressure microphone, which is built inside, and this represents the eardrum of the human. So this is a mechanical designed ear simulator to test according to IEC 60318. It is designed to test headphones. Insert phones is also possible. We can test the speaker in, not the speaker, the headset. You can test the speaker inside the headset, and you can also use it for testing telephones. We have another coupler, another artificial ear, which is the 60126 2cc coupler. This is a different approach from the other product. This coupler is having a 2cc volume, which represent the volume that you have inside the ear. So this is a cavity with a microphone inside, where the other one is more just the outer ear, and you measure it directly. So it's two different approaches. This ear is standardized, and it is typically used in the hearing aid industry. So typically you have the coupler here, you have a hearing aid on the side, which is mounted on the coupler with a tube so that it transfers the speaker signal through the tube, and then it's recorded in the coupler inside here. So this is a way to test hearing aids according to the IEC 6126. Then we have this other coupler. This is this is the 711 coupler. We have a test jig set up like this, where we have also the microphone inside, and there is a volume surrounding the microphone. But in this volume, we have small volumes, 4 small volumes that are altering the frequency response so that it's equal to a human ear. So actually this is the opening of the human ear, and then you have the volume inside, but inside you have all those sub-volumes that make sure that you have the same impedance response over the frequency range of the audible area. This test jig is typically used for insert phones, where you have it in the ear, so you can take an insert phone and you can put it on the top here, sealing the sides, and then you can do your test measurement. Or you can use it for hearing aid testing. In hearing aid testing, there is a tendency that is going towards using the 711 coupler in some of the tests. So they are typically using the 2cc coupler historically, but future testing is also done on the 711 coupler. This is actually the same setup as the first we saw. So you have the same opening here with the microphone inside. This is a 318 coupler, and this is a test jig setup for telephone testing typically. So when you use this, you typically use it together with the GR.A.S mouth to have a simulation of the speech signal and the hearing signal. So this is typically used in, you can use it separately in headphone testing or insert phone testing, but together with the mouth simulator, you're able to use it for headsets or telephone testing. The 711 coupler that I showed you just before is on some application linked together with a pinna, a mechanical pinna, which is solid and representing the ear of a human. So linking the coupler, you can say there is a split here, linking the coupler together with the pinna, you will have a full simulation of the ear, the inner ear, and also the pinna, the outside of the ear. And typically this kind of equipment is used for telephone testing, where you need to place the telephone close to the pinna and have the response of the pinna and outside of the pinna as well, with some venting here. You have 2 different kinds of leak simulators. You have one without leak and one with leak. So these are 2 setups that are describing different kinds of use of a telephone. Either you use it with a very close fit, which is no leak, or you have a more open fit, which is with the leak. So we have 2 different kinds of pinners that is being used together with the 711 coupler, and gives a full solution like this. Here we see a more historical product. It's the 6300 13 NBS coupler built a long time ago. In this setup, it's a 6cc coupler and not a 2cc coupler, and it's testing according to the NBS 9A standard for 6cc couplers. So this is one of the early models of an ear coupler, and we have a full test jig here that can be designed. It's typically used for headphone testing. You can also use it for headset testing or telephone testing of the speaker. Then we have developed a more special designed ear and cheek simulator. Based on all the standardized solutions with 711 couplers and 2cc couplers, we are developing and pushing the technology further at G.R.A.S. What we do here is we have a combination of a pinna made of rubber put on a test plate, and then underneath we have the 711 coupler. So the combination of this will make the ear pinna of the human more realistic. It have better properties according to acoustic testing of the insert phones. And actually this kind of pinna is more suitable for fitting the insert phone into the pinna. You cannot put the insert phone in a mechanical pinna because it will not fit. So the fitting is better for this kind of system for insert phones. Actually, this setup can be used for many different kinds of applications. You can test headphones, insert phones, headsets, hearing aids, and also telephones. I would suggest that the special area is, of course, the insert phones because of the good fitting that you can mount it, and also the headphones, where if you have a headphone test where you would like to add the ear and the dimensions of the ear inside the phone when you do the testing, this would be a suitable test jig for that. This ear is the KEMA ear, and KEMA is an industry standard for testing hearing aids and audio products. So the KEMA ear is what we took and integrated in this product in order to make it more realistic. We also have a QC coupler. This is a 711 coupler, which is built for production test. So if you have a production line where you have some equipment that needs to be tested, it could be telephones, where you have a need for fast testing of the telephone speaker. You can mount this on an automated production line, and then you can do fast testing. So it's a special design to make quality control for telephone testing in the production line. And it's using the 711 coupler, and it has a low or high peak simulator attached to it. So the G.R.A.S product is very flexible. We have many different kind of solution. They have a main base, so you can update from one product to another product. In order to visualize this, we have made a table, an ear simulator upgrade table, to show you if you have one product, you have to buy a few items, and then you can do some testing according to another application setup. So this makes it very suitable to be used on different kinds of tests within the audiology industry. If we go to mouth simulators, we can see that the first mouth simulator we have is a 44AA. This is reflecting a human mouth. It's a standardized design, mechanical standardized design of a human mouth, so that you have repeatability in your measurements and in the test signal that you use to test telephones, speakers, microphones, whatever you need to test. What you see here is, you can say, this is the skin or the cheek side, and the ring on top is reflecting the lip of the mouth. So this is a standardized mechanical mouth. Inside you have a speaker that delivers a sound signal that is suitable for testing telephones and speakers and headsets and different kind of equipment. We have two versions of the mouth simulator. We have one version with built-in power amplifier. So you don't need a power amplifier in your setup. This is all built into the mouth. So this is very good for fast connection to the data acquisition system. We have another type without this preamplifier. So if you already have the preamplifier, there's no need to get the full version. We have a simplified version without the preamplifier. Let's go into the area of human mannequins. Human mannequins can be used to test a variety of different applications. So headphones, hearing aids, earphones, telephones, headset, and sound quality. So the model that we have is the KEMA. And KEMA is the oldest model in the industry. It's more than 50 years now, and is the original design. It's based on a human. It's very human-like in the design. And you have the rubber ears here to reflect the pinna of a human being. So this mannequin is suitable for testing headphones, insert phones, hearing aids, and sound quality test. So typically we have a full database of HRFT of the KEMA, the response in different angles, and we have a lot of historical data on this human mannequin, as we have more than, I don't know how many articles, but there are written many articles about the performance of the human mannequin of KEMA. So we have two types of KEMA. We have one without the mouth, and we have one with a mouth. The one without the mouth is typically suitable for sound quality. The one with the mouth is suitable for telephone testing and headset testing. So all these, the mouth and building in the mouth, we are referring to the standards of ANSI and also ITU for P57 type 3.3 testing. So with the mouth, you are able to test both the speaker and the microphone of a telephone system. Yes. Here is a setup where we have mounted the telephone in a holder to the KEMA. So the holder is holding the telephone in different test positions. And these test positions can be adjusted very easily with all the different free parameters on the side. We have several parameters that we can change: angle, length, height, in order to position the telephone in the proper test situation. The advantage with the KEMA and the telephone test is that when you have a human mannequin, which is very similar to the human, it actually looks like a human, you will also get a performance like a human. So the reflections from the cheek, the nose, the lips, the entire face of the KEMA is very similar to a human being and the reflections in a human being. The telephone position, you can see the holder here. The size of the holder is very small, so it has a minimum of influence to the sound field. And this makes it very attractive for doing telephone test. If we look at some of the different ways to equip the KEMA, we have several different kind of ear pinnas. The ear pinna that we have are the small right, small left, large left. And then we have some VA styles which are suitable for other type of applications. All these types we have in a soft version and we have it in a hard version. So depending on the application that you need to use the KEMA for, you have to equip the KEMA with the correct ear for the measurement, or maybe have several ears so that you can do different kind of testing. And here is a table showing what ear is required for what kind of test. Or this is the recommendation by G.R.A.S, because you can actually use all the ears in different kinds of tests, depending on what you need. If we go into some of the acoustic test fixtures that we have, I would like to show you the telephone test fixture. It looks like this. You have a mouth, and then you have a 711 coupler placed in the jig up here. So underneath the telephone you have the coupler, and it's very carefully positioned here in a position suited for telephone testing. So this test jig is standardized according to ITU recommendations, and we have 4 different kinds of test positionings for the telephone. The special qualities about the test jig is that it's very acoustic neutral to measurements. The design of it is built in a way that it has a minimum of reflections from the speaker test signal and also the background noise in the environment. So the reflections from the jig itself is minimized. And also on the feet, you can see it has some special feet here which isolate from vibration. So if you have some severe background vibration where you are doing the test, we can isolate a lot of this vibration through the setup in the isolators in the feet. Another test jig we have is the hearing protector test fixture. This is for testing hearing protectors. There is a standard ISO 4869 that specify how to equip the test fixture. This is a stand with 2 sides. So you have the signal going in this way, and the signal that is measured inside is isolated from the outside. So there is a reduction or an acoustic isolation demand to this described in the standard. And this is around 60 decibels or something like that, is the reduction required in such a jig. We have developed this jig a little bit further than what the standards specify. So we are able to equip it with other kind of equipment. Like we are able to put in a human ear inside the side of the test jig. So this will make it more realistic according to the response and acoustic performance of a human ear. So you can set it up to measure with 1-inch microphones like it's described in the standard. You can set it up to measure with 1/2-inch microphones, or you can set it up to measure with a 711 coupler with the ear pinna if necessary. So all these extra features is the results of the discussions we have had with customers over the years. And here is an upgrade table with all the different pinners. I will not go further into that. The coupler application overview. If you are in doubt what the product, what features the product that we are offering has. There's a list here where you can see the product number, and you can see what area of test it is used for. So this gives a good overview of the different areas and what products you should look into. Also on the GRAS website, you will be able to find updated information on all these products, and also new development and new technology within the field of audiology testing. So this is typically where I'm asking questions, but if you have any questions, feel free to contact us, and we will do our utmost to help you and to support your business. Thank you very much. Hello, and welcome to this presentation on the world's best measurement microphone. My name is Kim Lumholtz, and I would like to explain to you why G.R.A.S is manufacturing the best measurement microphone you can get. So first, we will make a short introduction to who G.R.A.S is, and go on to why G.R.A.S is your partner, your preferred partner. I'll tell you a little bit about some measurement challenges that we see and things that you need to be careful about when you do measurements with microphones. The microphone quality is like a trust. So we would like to tell you that the microphone quality of G.R.A.S microphones can be trusted because we are testing the microphones beyond the limit. This we are doing with a principle we call microphone halt testing. Microphone halt testing is a test procedure that goes into different 4 areas of testing to make sure that the G.R.A.S microphone and the microphone that we deliver to you is the best. As a final, I will make a short example on why this is a good investment and a good long-term partnership. First, about the G.R.A.S company, I would like to show you the organization. 1 year ago, we got a new CEO, Lars Kjærgaard. He's running the company. The former owners, or actually the former CEO of the company was Peter and Per, and they are still the owners of the company. And Gunnar Rasmussen in the middle, he's the chairman of the board, and he is the one who made the company from the start 21 years ago. And it's also within the name you can see Gunnar Rasmussen Acoustical Systems. So he's the founder of the company and the one who started everything. The history of G.R.A.S, well, it started in 1994 by Gunnar. It's a family-owned independent company, and we have business partners in more than 40 countries worldwide. We have about 55 employees and growing towards 100, and we provide the widest range of measurement microphones in the world. So the focus of G.R.A.S is to be the preferred front-end partner in the field of acoustics. So we would like to deliver the best microphone you can get and the most advanced and durable microphone you can get. The industries that we support are aerospace, automotive, production line testing, consumer electronics, education and research, audiology, environmental monitoring. So these are the main industries that we support, and we design our microphones to be used in. We have standard solutions. So the standard solutions are the solutions that you can see on the website and in the catalogs and what's available. You have all the specification and data and information about the microphones. But we also do a lot of customization. The customization is done very close, in very close collaboration with the customer. So this is a partnership where G.R.A.S is adjusting the performance of the microphone to fulfill the needs of the measurement purpose. So approximately 40% of all our business is customized business, where we do adaptation to the microphone in order for it to fit into the industry. The microphones that we offer, the solutions, is centered on the capsule. So the capsule is the most crucial part. This is where you measure the acoustic signal, and this is where you get the data for your analysis. The capsule is typically mounted on a preamplifier that looks like this, and then we have different kinds of microphones that are not just simple standard microphones, but can be used for special applications. These can be surface microphones, outdoor microphones. We have low noise systems. We have sound intensity microphones to measure sound power. We have ear and mouth simulators to reflect the human being and artificial sound. So why is GR.A.S a good partner to team up with? First of all, we have a focus on the microphone itself. This is our key business, and we deliver the world's best microphone, which are designed to be used in real-life situations. So it's the most robust and most reliable microphone that you can get. Your ideas will come to life through our know-how. This means that we have the acoustic know-how to help you reach your goal. So if you have a development issue, you need to reach a goal in doing some measurements, we are able, with our acoustic knowledge, to supply a microphone that will be able to measure what you would like to measure. We have world-class service and support. So when you have an issue to discuss, we are open for the discussion, and we try to do our utmost to help you. If the microphone itself should be damaged in some way, if you drop it on the diaphragm or you break the diaphragm, we are able to remove it and replace it with a new diaphragm, make a recalibration, and send it back to you. And the cost of this is quite low. So on a long-term partnership, this has very high value for you. We have 60 years of experience built into every microphone, because Gunnar Rasmussen has a former history within acoustic for 40 years, and now 20 years more with GR.A.S, establishing the company and making it a microphone company. So this is the reason why GR.A.S is the best partner for you in this industry. So if we look a little bit closer to the microphone, you can see that it's durable. It's very durable. It has a protection grid like this to protect it against drops. So if you drop the microphone, we protect it with the grid. Also the diaphragm, I just explained that we are able to repair it, but also the material of the diaphragm and the way it's mounted is designed to be acoustic correct. The microphone itself is built for actual use, so it's not only a laboratory microphone. It is actually a microphone that you can take in the field and do measurements, and it will still do some good performance. It will be robust and be of good use in the field. So what we do, we test to the extreme in order to make sure that you can trust the microphone and the performance. So a GR.A.S microphone is built to be precise, reliable under all conditions, delicate as well extreme. Some different environments where the microphone are being used. For example, anechoic chamber. So typically this is not an extreme environment. This is where the microphone will have an easy life. But if you go into other environments like flight test, where you have a ground array here to measure on the flight when it flies over, it's a different environment. You have rain, you have wind, you have different things that can affect the performance of the measurement microphone. If you put it on a tank, you will have some vibration that will affect the microphone in order to alter its performance. So all these things, we are testing it. We're testing the microphone to be the best and to be the most robust. If we look at this is from an engine test where we have a flight engine and we are measuring the impact of the noise from the engine on the material close to the engine. So this is to test whether the noise is impacting or fatiguing the material of the surface. So this requires a microphone that can go up to very high temperatures, low temperatures, because it can be very cold at high altitudes. But also the robustness of the microphone is being tested in these kind of situations. It can also be production environments or even military tests where you have to measure on the exhaust of a F-22. So all these different applications or where the microphone is being used in the field, the microphone must be robust and reliable. So what we typically do is we have 5 critical parameters to test the long-term stability, short-term stability in case of vibration, shock, and handling. And what we look at is the resistance to drop, stability and durability, pinholes, repairability, resistance to shock and vibration, resonance frequency, stable distance to the diaphragm, and resistance to shock, temperature fluctuations, and the robustness. So these are some of the things that you should look for. The way that we are testing our microphones is done by HALT. HALT is highly accelerated live test. This is a test typically used in the consumer industry to test electronic equipment, but we have taken these tests up and applied them to a microphone in order to validate the robustness of the microphone. So we are looking into 4 different areas. We are looking into temperature cycle testing. This is a test designed to ensure the long-term stability of the microphone over many, many years. So typically the temperature is simulating long life of the microphone. Durability testing, which is designed to withstand changing environments, so changing environments in terms of humidity, this is being tested as well. We have vibration test designed to ensure a maximum robustness for vibration in different directions. And we finally have the mechanical impulse test. This is a shock and drop test designed to ensure resistance to mishandling. All these tests are described in a microphone HALT report. This report you can download on the GR.A.S webpage, and you can read more about the test procedures that we are doing for all the microphones and how to do them. The test, the temperature test, is a 350-hour test at a constant temperature of 95 degrees. So this is a very extreme test for a microphone, and typically the microphone is specified up to 50 or 55 degrees, but we go 10 degrees higher in this test to test it beyond the limits. The second test of the temperature area is a 400-hour cycle test, where we cycle the microphone, the temperature that the microphone is exposed to between 95 degrees and minus 40 degrees. So this is a cycling, continuously cycling in test in 400 hours. We have humidity testing. We do it for almost 100 hours at 90% humidity and 50 degrees. We have vibration test at 60 hours at 8G in different directions as well. Mechanical impulse testing, shock and drop. We drop up to 1 meter and we shock test up to 1 meter. And these tests are tests where we have the microphone placed in. First we have a test this way, and we have a test directly on the protection grid. And the drop test is a random drop test where we drop the microphones and we calibrate it afterwards to see what is the impact. And then we increase the height. So we start with 10 centimeters and go up to 1 meter. So why go to the extreme? Well, first of all, if we go to extreme, we can trust the performance of the microphone under normal conditions. So this will give us a better belief in the microphone performance, and we can also be sure that it will be able to measure the data. In production, for example, it will minimize the downtime of the microphone, so you don't have to send it for repair and calibration all the time because you are unsure about the performance. This will minimize the downtime, and you can be sure that the microphone is working properly. The system lifetime, the temperature test, is making sure that the microphone is having a long lifetime, up to 5, 10, or even 20 years. We have microphones in the field that has been there for more than 20 years now. Setup time will also be optimized, as you don't have to continuously set up and take down all the equipment because of errors or checks that is adapted. Uncertainty budget is describing the margin of the actual measurement data, that there is a smaller margin, so it's more precise, and there's a less uncertainty to the measurement data. And actually you can trust the measurements. You don't have to go and stress that your measurements will be good or bad, or be worried about it, because you have the best microphone. It has been tested under extreme conditions. The signal you get, the signal in is the signal out. So this is our goal, that what you are measuring is also what is actually going on. So for long-term stability, the conclusion is that through temperature we can simulate time. So this is a simulation of lifetime, and the tests are designed to show long-term stability. So this is the cycle test of temperature going up, down, and this is a 4-hour sample. So we do this in 25 samples, and then we make a recalibration of the microphone. Then we run another 25 samples and make a recalibration. And we do that again and again and again and again, and then we get the results for this. For the constant temperature test, we have 95 degrees, and we expose the microphone to this temperature for 50 hours. Then we make a recalibration. After the recalibration, we expose it to another 100 hours and make a recalibration again. And then another 100 hours recalibration, and another. A total of 350 hours for the microphone. So what we get is as result of these tests, and I will show you the result in a moment, there is an extremely long-term stability in the microphone, and we can hardly see any changes in calibration frequency of 250 and 1 kilohertz. There is a minor change appear near the resonance frequency of plus minus 0.5 dB. And this is the result. It might be difficult to see, but if we look at the graph here, the index here is 0 and 1. And all the curves, the first calibration is the blue one, and then it goes lighter. So all the calibration data, or the frequency response, are very close to each other, and we see a minimum of change of around 0.1 or 0.2 decibel after doing 400 hours of cyclic testing. If we do the same on for the second test with the constant temperature, it's the same result. There's a minimum or a maximum change of around 0.1, maybe 0.2 dB over the full frequency range after being exposed to 95 degrees for 350 hours. So this is a statement that the GRASS microphone is really, really solid in the temperature test and the stability of the microphone. So what do we get? We get a minimization of the downtime, we have a long system lifetime, and we can trust that the measurements that we are doing, they are correct. So of course we compared this to competitors. So if we look at the manufacturer X, we have seen the response in the same temperature test between 3 different samples. We see a difference of up to 1 decibel between the response. So this is a simple 250 Hertz calibration of the microphone. So this change up to 1 dB after 150 hours is quite a lot. And this is a proof that the GRAS microphone, in this case we took 40 AE, is not having the same difference. So as a conclusion, compared to manufacturer X, the GRAS microphone is more stable. We have done the vibration test and we have done the humidity tests also, but I would like to jump directly to a more important test, the mechanical impulse test. This is the drop test, showing the drop from 10, 20, 30, 50, 75 and 1 meter of a microphone. And the shock is up to 100,000 G through an acceleration of 2 kilo in weight. So we do this test in order to ensure the most robust microphone. So just a short video here.
At G.R.A.S, we know that all our customers are individuals. They all have different needs and requirements that are driven by the ever-changing world we live in. Our goal is to ensure that you have the right measurement microphone for your application. Whether this is met by a standard, special or customized microphone solution, our priority is always to help you achieve the best possible measurement results every time. At G.R.A.S, we know that to trust your measurement results, signal quality, stability and robustness are essentials. And because we also know how you handle and use the microphones in your daily work, we design and build them to perform under real-life conditions and beyond. When our R&D team develops a measurement microphone, it must undergo the most demanding tests to prove that it deserves to bear the G.R.A.S name. Using a series of highly accelerated live tests, we ensure that our microphones live up to the high quality and precision that our customers have come to expect and trust. Our hold tests actively accelerate the lifetime of a microphone by simulating the handling and use it is exposed to in real-life situations. We bake it, we humidify it, we shake it, and we even try to break it, just to make sure that you get the very best results every time. The first hold test we do exposes the microphone to rapidly changing temperatures to check its long-term stability. A new microphone has to undergo more than 700 hours of static and cyclic temperature tests that take it from -40 to +90 degrees Celsius before it can finally be released to production. To monitor and document the effects of the microphone hold tests, the microphones are validated thoroughly. Each microphone is mechanically inspected and calibrated for sensitivity and frequency before and after every test cycle. All this data is analyzed by our R&D team, and any corrections are made to ensure that the G.R.A.S microphone is of the same high quality that our customers rely on in their daily work. Another method to accelerate the microphone's lifetime is to expose it to high humidity. In our R&D laboratory, we humidify the microphones for nearly 100 hours at 90% relative humidity to ensure that the design is resilient enough to live up to our stability requirements. Any vibration test is tough, and our hold tests pushes the microphone beyond its limits. Our microphones are vibrated both horizontally and vertically with sinusoidal and broadband signals for 60 hours to test their stability and their conformity to real-life situations. Each microphone is calibrated before and after every vibration stress test cycle to check for any changes to its sensitivity and frequency response. Finally, our mechanical impulse stress test simulates the conditions a microphone can be subjected to in demanding test environments and due to unintended use. When shock testing the microphone, we mount one horizontally on a 2 kilogram weight and release it from a height of 1 meter. This shock test accelerates the microphone to more than 100,000 Gs when it hits the solid structure. The drop test simulates situations where the microphone by mistake is dropped onto the ground. Mounted in a fixture, the microphone is dropped from a height of 1 meter right onto a steel surface. At G.R.A.S, we design and build the world's best measurement microphones. Our microphones undergo the most rigorous tests to ensure that you can trust your microphone and hence trust your measurement results. Why don't you join the ever-growing number of G.R.A.S users worldwide? If you would like to know more about our microphone hold tests, then download a test report from GRASS.dk/hold. Whatever your measurement challenge, please visit GRASS.dk to connect with your local G.R.A.S partner, who will help you find the very best microphone for your application.
So what we saw in the movie was the setup that we are using at G.R.A.S to do the drop testing. And we have this fixture that we can set for 10 centimeters, 20, 30 and up to 1 meter. And then we do the drop testing. The result, as you see here, this is a half-inch microphone and quarter-inch microphone. This is half, this is quarter-inch. All the curves after the drop testing are pretty close to each other. So the conclusion is that after drop testing up to 1 meter, we still have a quite stable microphone. We see some small changes, maybe up to 0.2 or 3 dB in the middle section here, and the same occurs here. And it's a little bit different on the quarter-inch, where you see more difference in this side. So of course, the microphone will alter after being dropped or on the floor or being excited to a very big shock. This is clear. You cannot make the perfect microphone, but you can do the best to make it perfect, and that's what we are doing. So extremely small variations in frequency response, the same result for half-inch and quarter-inch microphone sets. We see no change at calibration frequency 250 Hz and 1 kHz, a microphone which is truly designed to be used. So these are some of the conclusions. If we compare the G.R.A.S microphone, the drop test, with other microphones, again we see the manufacturer X. This is the result of the drop test. Here you see the frequency response, and the blue curve is after 10 centimeters, and the light blue is after 20 centimeters, and the red curve is after half a meter. So comparing these results with a G.R.A.S microphone, you can see that there is a difference. There is actually a big change in up to 5, 6, 7 dBs in the midsection here, after being excited or being exposed to a drop of half a meter. If we look at the G.R.A.S microphone, it might seem that there is no effect, but actually the curves are just below the red one. So the changes are really, really small, down to 0.2 or 3 decibel maximum. If you see the manufacturer X, the difference can be up to 6 or 7 decibels. And you might think that the microphone is working properly, because when you calibrate in the low range, the low frequency range. So it might look that you have a good calibration and the microphone is working, but the response of the microphone might not be flat. And you will not see this danger when you're doing measurements. This is a very important point, that to have a microphone you can trust is more important. So as a conclusion, the Hall-tested microphones ensure long-term stability, robust microphones, and superior signal quality. It's designed to support your daily work, and it makes everything terribly expensive, right? This would be what you think when you have to buy a microphone which has been undergoing a lot of tests to make it the best in the world. It will also be expensive. But actually, if you look at the cost of a microphone compared to competitors, if we take a car manufacturer that do repeatedly test, for example, three tests every day in 1 year, so that is 220 working days. A microphone has a lifetime expectancy of 5 years. So over 5 years, this microphone is being tested every day, or undergoing test. The cost saving per day would be approximately 0.45 euro per day. Is it worth to save cost on the microphone because the car manufacturer has been offered a great deal, 500 units for a half-inch microphone set, and the seller is saying this microphone is the same quality as G.R.A.S? Is it worth this risk to do that? To me, I would be more happy about being relaxed and be thinking that the microphone I can rely, I can trust the microphone, I can trust the data. It's solid, it's robust, and it can perform under extreme conditions. Whereas if I bought a microphone for a lower price, which don't have this performance, I would be worried about the data. Is the data valid? Is it worth the risk of buying the cheaper microphone, which is maybe 500 euros cheaper? It's your decision. But you can find all the details on the G.R.A.S website. We have the report to download with all the test procedures and also the results of the tests. So go to the website and have a look. We also have a full Hall video showing how we do the test, all the separate tests, explaining everything and the value that you get from these tests we're doing. Thank you very much for your time, and